Good evening, guys. Today, the section D11 is today we are going to learn about the resolution and repeatability, and as well as the accuracy. And these are all the topics we are going to learn. And what is this all, and how these will be used at the robotics. These were some main things when we go with the axis rotation, and when we go with the particular type of the task, the job work we do. These were some main points which we are going to use at the robotics. And now we are going to see here the resolution. The resolution mean that of a robot is a future determined by the design of the control unit and is mainly depend on the position feedback sensor. Yeah, here you can see that the position feedback sensor. The position feedback sensor mean that whatever the position it will be, that position it is going to be give for particular area of a section. Sorry. And the position feedback sensor means that whatever the position is there at the particular area, it is going to be defined. Yeah, this was the exact position, and it is going to be give the feedback to the control system, which we are getting the output from the either else by the monitor or else by the something else. Whatever the feedback, I mean that the output we are taking, there it is going to be give us a result for the feedback sensor. And it is going to give the, not only it is going to be give the feedback, it is going to be sense the particular area. What was that area in a pinpoint location that is going to be interlocated by this feedback sensor. And it is important to distinguish the programming resolution from the control resolution. Yeah, how it will be the position oriented sensor will be works. One more thing that when we turn on the our system to in a particular programmable robot towards a particular automatically task, when it is in the normal the control system task, then it will not be executed like that. Why means on that time we are going to be control that robot in a particular area, particular dimension, by using of the pinpoint location. But when we go in the programmable resolution, when we turn on to the particular online mode or else it is in an automatic mode, on that time the programmable resolution makes the important role. And it is going to be detail the particular area of any feedback resolution in a particular dimension. It is going to be pinpoint that the particular area, yeah, this is my area to be near in drop the box or else to make collection of that particular job. It is going to be detailed. That's why we are here they have been mentioned that the programmable resolution from the control resolution. Yeah. And the programmable resolution is the smallest allowable position increment in the robot program. Yeah, it is in the smallest thing. Why means the command modes we are going to be give for the program, like in a the p1 the p1 position, and the p2 position, the p3 position, the move command, and the return command, and pick command. This is all the commands you can note down at anywhere. P1 position. Yeah, wait a second, I am going to write p1 and p2, p3. And firstly there should be a move command, move, move command. This is the move command. Then after the p1 command will be executed, mean that the point one we are going to be give that execution process. Then after it is going to be a point two, then after it is moving to the point three. And after the point three, the our job condition has came, and here we have to give the pick, pic, pick. And again written, RETUN, written command, and written after again it is going to be a move to which position? The position of P1. Move P1. This was the robot coding which we are going to exactly pinpoint location which we are going to mention, and it is by flowing of in the particular way by using of the particular command modes. If we go within the command modes of manual controllability, then we can use this, or else in the manual controllability we are going to use the XYZ direction. That XYZ directions it is going to be use that like XYZ directions means you can learn here. XYZ directions mean, yeah, plus X minus X plus Y minus Y. Like this, I'll be saying you can write plus X plus Y plus Z minus Z, A B plus A minus A plus B minus B plus C minus C. This was the command mode, which this was the buttons, or else which was the pinpoint locations that which we are mentioning in the axis rotation in the TB pendant. This was the command. When we press the plus X, it moves on the left side. When we press in a minus X, it moves on the right side. When we press the plus Y, it moves to upward in the Y direction. When we press the minus Y, it comes to downward in the Y direction. When we press plus Z, it goes on a Z axis. When we press minus, it comes on a z-axis to the downward. Like the resolution and the all the positions will be at like this. According to this position, according to this particular thing, it is going to be get the exact position of an exact robot. And by using of now here we can get it one more thing. And now we are getting the position here, and in this position the increment robot that the program and referred to as a basic resolution unit. Now here we learn that the basic resolution unit, what do you mean by that? The basic resolution unit, the basic resolution unit is that the particular thing which we are using, be basic resolutions mean that the in a particular joint, in a particular link, there will be the resolutions, there will be somewhat the rotations in a smaller part, the smaller angular part. That smaller angular part also we are not going to be neglect that, and by using of these commands we can access that smaller parts also in the resolution manner. And that's why we are using the resolution format. And now here you can get it that the IRB 2000 ABB robot, the ABB is in a company, and the IRB 2000 is in the particular the weightage, or it is in a RPM for the particular robot. That's why they mentioned that the IRB 2000, the IRB 2000 makes the, it is, yeah, the IRB 2000 makes the robot is approximately minus sorry 0 to 125 mm. The 0 to 125 mm means that now here you will be getting that it is going to be give the resolution points from 0 to 125 mm. In this smaller part of a resolution, it is going to be give the exact accuracy, exact resolutions. in this smaller pot, 125 the rating of that particular resolution. And this is the videos of the ILP robot of ABB company, 2000 resolutions. And here you will be getting the 125 resolution on the linear axis only. The particular dimension is the linear axis only, not any other axis will be executed over here. Only at the linear axis it is going to be executed by this type of Then after, when we go within a next level, the control resolution is the smallest change in the position that the feedback device can sense it. Yeah, in the control resolution, when we go within the TP pendant, the feedback system mean that every particular angle has the particular limitations by or else in 90 degrees or else in 360 degrees or else 180 degrees. These all the particular limitations will be when we go within the particular momentum of a hand TV pendant controlling, then we will be getting somewhat errors. How the errors will be occur? We didn't see that. Yeah, there is a limitation. If the movement of an angle, we are going to be give more power to that, and we are going to move that particular robot in a particular dimension to until the endpoint. Then when it is going to be touch for the particular the feedback sensor, it is going to be detect that yeah, it has been errored and it has crossed the limitation, and it is going to be give the beep sound. And according with that, on that time again we has to give the reset at the TV pendant. Then after again we has to execute our job condition by on off in a servo motors. Yeah, like that the feedback control system will be works to give us the feedback system. Yeah, you are at the exact this position, and this position is in a wrong for you, and this position is in a right for you to be do the particular task. And this is was the position it is not useful for you to do the particular task. It is going to be make us to be perfect in particular doing of the task. For example, you can see that assume that the optical encoder which emits the 1000 pulse rate resolution of the shaft is directly attached to a rotary axis. Yeah, here you can see that the amplitude of a 1000 pulse rate resolution. 1000 pulse rate resolution bit for the 1 second it is going to be resolute in a 1000 pulse rate. And here clearly they have mentioned that the pulse rate, and the pulse rate resolution the soft directly attracted to the rotatory motion. And here you have seen that in a linear motion, and here it is going to be act in the rotatory motion. When we go within the rotatory motion, they are going to see the pulse rate resolution. And according to that pulse rate resolution, whatever the pulse rate resolution we are giving, either else in a 100 pulse rate or else 120 pulse rate or else something another pulse rate example we are giving for that particular, according to that particular pulse rate, it is going to be give the axis per resolution. For that axis per resolution makes the uh, rotatory axis in a particular area. And this encoder will emit one flash for each of 0 to 36 degrees of angular displacement. Now you can see that here we are giving not only the pulse rate, not only in the rotatory axis and the linear axis, not only at the axis also, and it is going to be give the angular displacement of the soft. The angular displacement of a soft means that whatever the rotating motion of the robot servo will be, or else the motor will be, on that time the robot they sorry, for the motor there has one soft. That soft will be in the stationary condition, and that angular displacement will be in the 0 to 36 degrees. 0 to 36 degrees the angular displacement will be for that particular motor. And that particular motor it is going to make the particular angle to be rotate in a particular axis. This all the thing about the control resolution and the resolution. And here you will be getting the control resolution axis of the motion angular increment smaller than the 0 to 36 cannot be detected. Yeah, Here you can see that here they have given it the 0 to 36 degrees angular displacement. Soft will be in the stationary condition and it is going to give the angular rotation. But here they mentioned that below the 0 to 36 degrees of displacement of angular increments, it will only give the access control for the robot. This was the limitation for particular area for this, and after the particular rotation of this, it will only give the access for to be rotate the particular task variance in another resolutions. In this case, both resolution can be replaced with the one term, the system resolution. The all the resolution can be replaced with the one term, that is a system resolution. That system resolution is going to be explained that yeah, it is this was a resolution. It makes us to be do the particular task by using of this. Okay, and here we can see that the system specification position as, and what was the position of an particular angle will be, and the resolution will be executed, and the resolution how it is going to be in a particular access control, and user required position u and system specified position s. User required means particular person, okay, who is a gesture, who is going to give the commands. He is in the user request position, and the user request position is this, and the system specified position is this. How the system will be specified? Yeah, we can see that this is in a user, and here the system specified location, and how was the accuracy will be defined, and how was the accuracy will be calculated. According to this, the accuracy will be calculated a by 2. Whatever the thing will be, the distance will be the distance by 2. You are going to do by using of that distance a by 2, you will be getting the particular accuracy and the particular position to do the access control for the particular resolutionary access. And repeatability, here you can see that the 6s a plus and plus or minus a 3s mean the 6s are of the plus or minus 3s mean, and here the total length of this distance is 6, and then they are going to do the a by 2. When we do by the a by 2, out of 6, how it will come 3, and like that here either else it is in a plus side or else in a minus side. It we have previously we have seen that plus x minus x, plus y minus y, like that. So here we can see that if we the particular angle it will be goes and it will be moves towards on a left side, it will be in a plus 3. It will be goes in the right side minus 3. Then according to this we are going to calculate the repeatability of the particular angular variance, and the control resolution after that the repeatability of a resolution we can get it. Then after we can go with the control resolution, and how was the control resolution is there, and how it has been executed. Here you can see that how was the control resolution, the linear axis in the control resolution is 3 to 36 degrees, and 3 to 36 degrees means the 36 degrees you have to intercalculate it with the 180 degrees, and then after whatever the answer it will be coming, you have to divide it by that answer 2 in 2. Then after you will be getting the particular axis rotation in the control resolution axis, and Emax is equal to A plus a modeling error plus a 3s. The modeling error is that how much error has been occurred in a particular task. That error, how you are going to be repeatability and eradicate that error by using of this particular dimension. That error you have to mention over here a plus whatever the a value is. A value is the control resolution. The control resolution. A value means the control resolution. The control resolution you are going to give here plus a modeling error. The modeling error, what was the modeling error will be? The modeling error here you are going to mention plus a 3s. Then after you will be getting the distance or displacement of a particular area of cross section. Then according to that, the particular robot is going to be moved from one place to another place to do the repeatability task or else the multiple task in the short variancy of the time. And here you can see that the our robot wished and show as an a point and a target pointer. The target point in the wrist point will be that the wrist point will be in the either in the two sides, that the in the two sides we are going to be calculate in a particular dimensional way. In the control resolution, in this between this all the resolution will be in the control resolution. Then after we have to calculate from the target point to the our robot wise robot wish, it is in the accuracy. Then after we will be getting the accuracy, the address variable point will be pointing in the particular time or in a particular variance of in a particular area. Then we are going to be intercalculated with the particular control resolution, and finally we are going to be get the control resolution how it has been and what was the target point of that particular area, and according to the target point in the control resolution, how is the product is going to be execute and how was the robot is going to be move from particular dimensionally of an area. And actual resolution position, actual targeted position, the feedback scale, and feedback scale and repeatability accuracy, and here the distributions, sorry, differentiation. And here we has to find the differentiation, and here we are has to find the accuracy like this from the target point. And if we measure that what was the center point will be, it is called as a target point, mean that a by 2 it is in the target point. And from here there will be the feedback scaling. The feedback scaling, how it is going to be scale the feedback, and whatever the resolution of a position from the accuracy, it is going to be flow in a particular direction. The displacement it is going to be calculated according to the displacement, and then after the actual repeated position, it is going to give the accuracy of the particular task. Now we are going to learn about the accuracy. The accuracy, how it will be work. And previously we have seen that in the resolution they have measured the accuracy also, the displacement also, and according to that accuracy in the displacement, the working piece will be worked and how it has been executed in a particular area of the dimension. And accuracy refers to being a robot ability to position it wished and the desired target point within the work volume, and it is defined in term of spectral resolution. At first accuracy depends on robot technology and how closely the control increments can be defined for each of the joint motion executing for the mentioned the mechanical inaccuracy with the include the robot manufacturing quality. And here you can see that the accuracy how is the important when we are doing the robot manufacturing system. The accuracy is more important to particular area of domain. And when we are going to do the particular area of the domain in the robotic systems, in the industrial robotic, when we go with the industrial robotic, the particular area of the system will be in the pinpoint location, and how it is going to be detect the targetable location. According to the targetable location, the targetable location means it is the exact position which we are going to be take the particular job from that particular location. That's why we are going to be go with the job condition of the particular target point. And when we are going to do the particular target point, the accuracy is more important, and the precision manner. And how was the precision manner and the accuracy we are going to give, and we are giving the pinpoint location for the exact that particular task by using of an accuracy. How we can give the by using of a displacement, and we have to calculate the particular area of a dimension according to the distribution. The statical distribution it makes the mechanical inaccuracy with the statical distribution. The statical distribution is means that uh, how was the particular area from here to here, and we are subdividing into a particular parts, and that particular parts it is going to be defined that yeah, this is in a one part, this is one part, this is one part, like that. The according to that particular parts, it is going to be treated the statistical distribution. It is going to be distribute particular area of a resolution for the particular task, and it has been executing. And after that, in that case, accuracy is defined as in one half of the spectral resolution. Here you will be using the spectral resolution for this accuracy. The term accuracy of a robot, accuracy of a robot defined as one half of the spectral resolution. The term accuracy in the robot is often confused with the term resolution and the repeatability. The final accuracy of a robot system depends on its mechanical inaccuracies, the computer control algorithms, and the computer control algorithms and the distribution of repeatability mean that when the particular robot is there, in that particular robot we has to give the accuracy for that, the angular resolution we has to give for that, and as well as that the mechanical distribution also we has to give for that. In that mechanical distribution and the angular rotation, we are going to use the control computer algorithm. The control computer algorithms mean that the control computer algorithms, it is going to be give the particular variance of a task and the task repeatability by using of an algorithm variance. Algorithms means it is like yeah, when we use in a particular code, there will be in a one certain type of libraries like that. The algorithms also work that the neural network connectivity. When we go within the fiber looping system and the fiber looping connectivity, most of the microcontroller and the robot is connected by the fiber looping of wires. On that time we has to give the particular variance of a signal transmission. For the signal transmission and the particular variance of time, it makes by the using of the algorithms of a command. The algorithms it is making to distribute the particular variance of a what I can say that yeah, the particular variance of the signal transmission from one place to another place for the particular task. And the system resolution, the mechanical inaccuracies are cases mainly by the backlash and manipulated joints and the behind of a lens. Yeah, previously we have discussed that when the particular area of a manipulator, it is going to be rotated from one place to another place, and the particular angle rotation there has a limitation. When it is going to be collide with that particular limitation, and the feedback control system, it is going to be give us the feedbacking system. Yeah, it has been correlated with some particular external field, and you has to be stop your job condition automatically. It is going to be stop. Why means the servo controls will be off when the feedback control system will goes for in a particular area of a controller. Then again we have to reset that particular programming, that reset that particular programming, and when we go to the previous programming, and the control system is going to be execute that. On that time we again we has to give the power supply for the particular servo motors or in a motors. Then after it is going to be execute that particular task in a from continuous variancy. And now here we can learn that yeah, let's see, wait a second. Yeah, here written position are and the programmed point, written position and the programmed point, and this is in a triggering point and targeting point. Here we can see that this is in a target point. From here the target point to the repeatability and the programmed point. The programmed point means that here you can see that it is not in the exact straight line, somewhat different, somewhat cross section is there, but the exact position is this. We can say that when we are going to use the programming point, we are going to assume this. If you assume this point, you will be getting the program in this point only, but executed by this point only. And when we are going to give this point, then it is the program is going to be executed this particular point. That was the programming task. Why means the we has to neglect the particular the delay time of a seconds in the particular area of a dimension of robot. That when we delay the particular timing it is going to give the accuracy and repeatability error. It is going to give the repeatability error by accuracy error. The accuracy error how it is going to become from the repeatability of a task and the targeting point, from the targeting point to repeatability of the task in a one line axis. In the angular axis it is going to be repeated, and in that angular axis the repeatability error it is going to give us. And repeatability error also it will be in the plus or minus. In the plus or minus mean that when it is going to be a minus condition mean x direction, or plus condition means a y direction. Minus and mean that the plus or minus means minus or plus direction, either else in the left side or either else in the right side. The execution points will be executed according to our job conditions. And then after we can move on to the next slide. And here there is the repeatability. When we go with the repeatability task, the repeatability is in the um, statical term and associated with the accuracy, and it describe how a point is repeated. If a robot joint is instructed to move by the same angle from a critical point a number of times. Yeah, here you can see that the statistical term associated with the accuracy. The repeatability has been associated with the accuracy. Why means in the accuracy we are going to be, measure the sorry, in the resolution we are going to be, measure the accuracy, and the repeatability we are going to be, measure the accuracy only. That's why it is interstagnated with the repeatability. No, sorry, the repeatability has interstagnated with the accuracy, and it describes how a point is repeated. If a robot joint is instructed to move by the same angle from a certain point a number of times, from one particular point it is going to be repeated in a number of times, then after all with the equal environment condition. Yeah, it is going to be repeatable in a particular variance of a task and in a particular environmental condition. When the working space, what was the working space of a robot, it will be in that particular working space of a condition only it is going to be execute the particular task. That is called as the environmental conditions. It will be found that the resultant motion lead to different displacement. Yeah, when we are going to calculate the accuracy, exactly we has to calculate the particular displacement, how much it has there, and what was the distance of the particular robot. And by using of that distance, then we are going to be getting the triggering point. How is the triggering point will be getting the a by 2. A by 2 we are doing on that doing of an a by 2, then the displacement will be adds on that. This was the displacement, how we are going to be calculating particular area. All through a target is always missed by a large migrant. If the same error is repeated, then we say that the repeatability is high and the accuracy is poor. Then we say that the repeatability is high and the accuracy is poor. When this type of an execution, the same execution error repeats, the same error is repeated. When if the same error is repeated, then the particular area, mean that our display, our output, it says that the repeatability is more and the accuracy is poor in condition. It is going to detect us. And repeatability does not describe the error with respect to the absolute coordinates. Yeah, it never, the repeatability never described that error in a particular dimensional of a displacement area and a particular coordinates. It will only give the coordinates and it will only give the absolute coordinates for us for detecting of that particular task. And system repeatability is the potential deviation from the average of a displacements, potential displacement of an average displacement Example, plus or minus 0 minus 0 to 2 mm indicates. Yeah, there we have seen 0 to 3, and here we are saying plus or minus 0 to 2 mm indicates that any point might be as such as 0 to 2. Here the plus or minus 0 to 2 mm indicates that the position of an might be as such as 0 to 2 mm behind as a short of the centers. Yeah, how is the repeatability will be mentioned by using of this. Here there is a plus or minus, and here there is only the 0 to 2. The plus or minus has been neglected, means that the triggering point has been came for the exact location in the center of repeatability pattern. Yeah, here you can see that how was the process has been done and how it has been executed in the repeatability pattern. Most robot manufacturers provide a numerical value for the repeatability rather than the accuracy of the robots. The reason is that the accuracy depends upon the particular load. Accuracy depend in which it has going to be depends in a particular load variance. How was the load will be applied by using of a torque condition in the motor? How we are going to apply the load by giving the weights uh, in the particular torque. And if you go with the motors, there they can say that the 10 hp, off hp, 1 hp, what was that horsepower. And horsepower means that what was the weight load is going to act on that till the 1 horsepower weight you can use this particular motor. More than this, the motor it cannot stagnate, it can stagnate, but in that particular variance of the limit only it can stagnate, but it cannot give some more accuracy for that. Like that only here also the limitations will be executed over here. Okay, now we can see that the particular repeatability time variances and how was the repeatability is going to be execute and what was the time variances. And here we can see that there will be in a one what can we can say, the repeatability time meter. And here in the time meter from 0 to 98 will be when it crosses to when from initial stage it starts from 0, and when we pressure it is going to be increase the weight, it is going to be applied on this particular point. The particular point it is going to be detect that how much weight it is going to be come. When we are giving the weight for this particular point, it is going to be go inside, and according to that inside then the particular angle it is going to be give that, yeah, this much weight load has been applied on this, yeah, 10 mm or something in the 10 milligram or something else, according to the particular task variances. It is going to be noted, yeah, 10 has been applied, 20 has been applied, 30 has been. The particular limitation till the 60 we can use when we are in the manual condition. When we go with the automatic condition, until the 90 we can use, but in the manual condition we can use till the 60 only, not till the 90. Okay, and here we have a one small calculation how we are going to get the accuracy position. And this was the formula for getting of this particular resolution. EV is equal to R1 plus R2 by 2 into K1. EV is equal to R1 by R2 means the repeatability of the repeatability. How was in the R1 position and how was in the R2 position. If we think that in the R1 position 00015 into R2 position, it will be in a 4.56. Then after it is going to be give the particular sorry, when we are going to be assume the r1 plus r2 by 2, we are getting the point that the point 00015 the resolution it has came, and repeatability it has came, and the k1 how much that 4.56. We are going to multiply with the 4.56 with the resolution, and after that we are going to get the 0.0000684 we are getting. And the alpha repeatability we are giving that ev by 5.15 r1 and here we will be getting that the EV by 5.15. By dividing of an EV by 5.15, we will be getting the point 0.0000133. Then after we are going to what we are going to get that the exact percentage. How was the exact percentage? We are it is going to get it, that we are going to get, and then we has to give the multiplication by the totaling of 100 into EV. How, what was the EV? 0.0 sorry, 0.000684 by tolerance. What was the tolerance? Is the 0.135. Oh, sorry. The 0.10 is the tolerance. After the calculating with the tolerance and the particular EV, we are going to get the 6.84 percentage. This much percentage, yeah, which I have said you at the manual condition. This was the 60 is the limitation. The here also you got that the 6.84 is the answer, mean that the 60 is the particular limitation at the manual condition. When you turn on to the automatic condition, then you will be getting the execution of a 90, but in the manual condition till the 60 only you have a limitation for the repeatability. And here you can see that the sim and how it is going to be mean it, and how it is going to be calculate we are in a particular variance of task. Ci for in a mu is equal to x plus or minus z is alpha is equal to by square root of n, and we are getting an individual Simpson. And how it is going to be executed? X means mean and Z means competency of level, and here we will be getting the sigma means variance in the population, and um, this was the it is going to be the sample size. This all we have been defined according to the particular task we can use in the repeatability. And the execution points, it will be done like this. And here we can see that the smallest increment, the system resolution you will be going to see here. I hope that all you have understand what was the accuracy, repeatability, and the resolution, and how we are going to select that the particular task by using of the accuracy and the repeatability and which clock it will be, and that we are going to use, and it is the particular what we can say that it is the right clock which we are going to execute our task. And the smallest resolution is the smallest increment by the system and display or measure. A system can have a higher resolution with the poor repeatability and accuracy. The resolution is a primary, corner, and application regarding speed control and surface finishing. Now you got it there. The resolution height will be work, and it is the surface speed control and the sorry it is going to be used for the speed control and the surface finishing. It will be used for particular task. Okay, now you got it that how it is going to be. Thank you so much. This was thank you so much for today's class.